In this video, we'll discuss regarding reflector antennas. So, what is meant by the reflector antenna? What is the basics of reflector antenna? What are the various types of reflector antennas? Okay. So, the reflector antennas are the most important in microwave applications. Okay. So, at microwave frequencies, the physical size of the antenna um, of high gain antennas becomes so small. Okay, so generally the size of the antenna is inversely proportional to the frequency. If you are operating at lower frequency, the size will be more. At the same time, if you are operating at higher frequency, the size will be less. So the relationship between operating frequency and the size of the antenna is inversely proportional. Okay, so at microwave, at microwave frequencies, the physical size of the high gain antenna becomes so small. Okay, so that are practically any suitable shape reflector can produce desired directivity. Okay, in a reflector antenna, another antenna is required to excite it. So the antenna which is used to excite the reflector is called as the primary antenna. What are the examples of that primary antennas which excites the reflector? That are horn antenna or slot antenna or an array of dipoles. An array of dipoles. Okay, so the used reflector antennas are, it may be horn antenna, or it may be dipole antenna, or it may be slot antenna, or an array of dipole antennas. Okay, so the antenna which excites the reflector antenna is called as primary antenna, while the reflector antenna is called as secondary antenna. While the reflector antenna is called as secondary antenna. In general, the reflector antenna may be represented in any geometrical configurations. The most commonly used reflector antennas are, they are plane reflector, corner reflector, curved and parabolic reflector. Okay, so using reflectors, the radiation pattern of the radiating element can be modified by using a large metallic plates as the reflector. So the backward radiation from the antenna can be eliminated, thus improving the radiation pattern of the antenna. So finally, by using this reflector antennas, we can increase the gain or directivity. Okay, so reflector antennas are the high gain antennas. Okay, the main purpose of the reflector antennas are, they are high gain antennas. Okay, so which is used for long distance communication. Okay, which is used for long distance communication. Okay, so what is the main purpose of a reflector antenna? The reflector antenna definition is an antenna that is designed for reflecting the incident electromagnetic signal originating from separate source. Okay, so these are various examples of reflector antennas. I have told that in a reflector antenna. Okay, so this is a reflector. Let us consider here what is this one. This one is a reflector. Okay, so here what you have taken, this is the primary antenna or driven element, and this is reflector. So which antenna that excites the reflector is nothing but primary antenna. In this here, this is the dipole. So what are the examples of the primary antenna? It is a dipole or horn antenna or a group of dipoles. Okay, so here what is the shape of the reflector? Here the shape of the reflector is flat shape. Okay, here what is the difference between this diagram and this diagram? The difference between this diagram and this diagram is, the first diagram and second diagram is, here the reflector shape, the back on the back side, the reflector shape is large. Here the reflector shape is thin. Here the reflector size is very, very less. Okay, so here I have taken a flat sheet. Okay, here I have reduced the flat sheet. Okay, here I have taken a thin reflector. Okay, so if you observe here, this one is the primary antenna and this is the secondary antenna. This is secondary antenna. So the one which excites the reflector, it is called as driven element or primary antenna. Let us see here. Here what I have taken. Here I have taken two sheets. Here I have taken two sheets. This is one sheet. This is one sheet. This is another sheet. Okay, so that is another sheet. Okay, so two sheets I have taken here. I have taken the driven element. So this is the corner reflector. What is the difference between this antenna and this antenna? Here there is a primary antenna is there. Here no primary antenna is there. Okay, so primary antenna radiates from the primary antenna radiates on the reflector, and the signals will get reflected back again. Here there is no primary antenna. So which is having primary antenna, that is called as active corner reflector. Which doesn't have any primary antenna to excite, that is called as passive. Okay. Here this two flat sheets are joined like this. Two flat sheets are, so this is one sheet, this is another one sheet. If I join like this, okay. So if I joined like this, okay, so I am getting a corner. This is one sheet, another sheet. If I join like this, okay, so a corner is coming into picture. Okay, so this is a corner antenna. Okay, so here what is the shape of the reflector here? Here first one, you are using flat sheet. Here you are using two flat sheets combined to form a corner. Here what is the shape of the reflector? Here the shape of the reflector is parabolic. Okay, so this is my feed element. Okay, so from this the rays will fall on the feed and all the rays will move in same direction. Okay, so this is another setting. Okay, here what is the difference here? How many primary antennas are there? Here only one primary antenna. Okay, and how many reflectors are there? Only one reflector there. But if you observe here, okay, so here primary antenna is there. This is the first reflector, and this is second reflector. So the wave first falls on the first reflector and gets reflected back and falls on the second reflector. So this is the another example of a reflector. So, okay, so this is elliptical reflector. This is hyperbolic reflector. This is circular reflector. These are the various examples of reflectors. These are the